Hello and welcome to GitHub Actions. I'm Andrew Conniff. I'm a Microsoft Technical Trainer specializing in data and AI. Here we're going to talk about GitHub Actions, so let's just dive right in. GitHub Actions are powerful automations built directly into the GitHub environment, designed to streamline and enhance our development workflow. At the core, Actions allow us to automate tasks like building, testing, and deploying code, making continuous integration and continuous delivery much more accessible. These automations are defined using YAML files that live within your GitHub repositories. So your workflow definitions are versioned right alongside your code. Actions can run on GitHub's own hosted runners or on self-hosted machines, giving you flexibility depending on your project's needs. Plus, there's a vast marketplace of pre-built actions that you can use to quickly add functionality without writing it from scratch. GitHub Action workflows are driven by events, making automation in your development process both powerful and flexible. In GitHub, an event such as a code push or a pull request or a scheduled time triggers the workflow, and then each workflow is a set of instructions written in YAML that tells GitHub what to do when that event occurs. Inside a workflow, you can define one or more jobs, and each job is made up of steps that use actions. These actions are reusable pieces of code or automation that perform specific tasks, like checking out code, running tests, or deploying applications. GitHub provides starter workflows to help you get up and running quickly, and we can define our own by specifying events, jobs, and steps. For example, a workflow might be triggered on every push to the repository, running a series of jobs like building our application or running tests. In GitHub Actions, workflows are made up of several standard syntax elements that define how our automation runs. At the top, we can give our workflow a name. It's optional but recommended for clarity. And then on the field that specifies the event that triggers the workflow, such as code push or pull request, we can put that there. Each workflow contains one or more jobs, and each job defines the environment it runs on using the runs on field. This is going to tell us what type of machine it runs on. So within the jobs, we list out the steps that should be executed, and then we can include the predefined actions with the uses keyword, like uses action, or running custom commands like the run keyword, which would be for scripts. This structure makes it easy to organize and automate complex development tasks in a clear, repeatable way. GitHub Actions use the events to trigger workflows, making automation in our development process powerful and flexible. And events are simple things that happen in your repository, like the code being pushed or the pull request being opened, or even a scheduled time. So when one of these events occurs, it tells GitHub to start a workflow, which is the set of instructions written in YAML that defines what should happen next. For example, you might set up a workflow to automatically run tests every time someone pushes code, or to deploy your application when a pull request is merged. In GitHub Actions, jobs are the building blocks that organize and execute the steps needed to automate your workflow. Each job is a collection of steps, like running scripts or using actions, that are executed in order. By defining multiple jobs, you can structure your workflow to handle different tasks, such as setting up a server in one job and building your application in another. These jobs run in parallel by default, which means we can speed up our automation by having several tasks processed at the same time. If you need certain jobs to wait for others to finish, for example, building only after setup is complete, you can set dependencies between them to control the order of execution. In GitHub Actions, runners are the machines that actually execute the steps in your workflow. Think of a runner as the worker that carries out your instructions, whether it's running shell scripts, building your code, or deploying your application. GitHub provides hosted runners for popular operations on systems like Windows, Mac OS, and Linux, making it easy to run jobs in a consistent environment. For more specialized needs, you can use Docker containers on Linux or even set up your own self-hosted runners, which are especially useful if you need custom software or hardware. However, for public repositories, it's best practice to stick with GitHub's hosted runners for security reasons. GitHub Actions make it easy to see the result of your automated workflows right inside the GitHub interface. When you run an action such as building your code, running tests, or deploying an application, the console output is displayed directly in the GitHub UI. This means that you can quickly check whether your workflow succeeded, spot any errors, and review detailed logs without leaving your browser. The immediate feedback helps you and your team stay on top of your development process and address issues as soon as they arise. GitHub Actions makes it easy to use specific versions of actions in your workflows, ensuring consistency and reliability in your automation. When you add an action to a workflow, you can specify the exact release you want to use by referencing a tag like v2.0.1, a branch such as develop or latest, or even a unique SHA hash. This flexibility means you can lock your workflow to a stable version, experiment with the latest features in a development branch, or guarantee that your automation always uses the exact code you've tested. By controlling which version of an action runs, you reduce the risk of unexpected changes breaking your builds or deployments. And this concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.